Hello world! Today we're going to be talking about C++, more specifically the dark matter in C++. And what does that mean? Well, I declared an empty class here called myClass. It has no code inside, but actually there's some dark matter here. There's stuff that we cannot see, we cannot directly measure by looking at the code, but the compiler puts it there for us. So let's talk about that a little bit. So the first thing is, okay, this is an empty class, it has nothing, but I can instantiate it, right? I can declare a variable of type myClass, and some constructor will have to be called, right? So the compiler generates for us, in some cases, it generates for us a constructor that takes no arguments and does nothing. And this is called the default constructor. These member functions that are generated by the compiler are called the special member functions. And there's not just the default constructor, there's more. So my question is, how many member functions does an empty class have? And the answer is, it has 4. Okay? But it has 4 if we're talking about pre-C++11. If we're talking about C++11 or later, it actually has 6. So what are these member functions? Why do they exist? What do they do? And when are they called? We're going to talk a little bit about that because that's a very extensive subject that we can talk about for hours. So we already have here the default constructor, and of course, you can also destruct this class. So the compiler also generates for us, in some cases, the destructor. And the default destructor basically just destroys everything, doesn't do anything special, just like this, takes no arguments and does nothing. And we can also make a copy of that value. So there's a special member function called the copy constructor, which takes a variable of type myClass and copies it. Actually, I should say that the idea behind the copy constructor is that it should copy the value, but actually the user can write their own copy constructor and do anything they want to. There's also assignment that is somewhat similar to copy. So we have these 4 here, and they are the 4 special member functions pre-C++11. But on C++11, we have these 2 new special member functions, which is part of move semantics. So C++11 introduced this idea that maybe you don't want to copy. Maybe the thing you're copying will go out of scope soon and you're never gonna read it, so we can just steal its resources, so that way the program is faster. And the compiler in an empty class will actually generate one for us. This is the move constructor. You can see it's pretty similar to the copy constructor, but it takes an R-value reference, meaning basically a value that will be destructed soon. That's the basic idea. And also that's the move assignment operator. And these here are the 6 special member functions. So now that we know what they are, let's see how are they called, what do they do, and what the compiler generates for us. So now before we continue, let's just look at my IDE is going crazy right now. It's highlighting a bunch of stuff, and that's because we have warnings here. Let's look at them. First of all, we have this here where I wrote assignment wrong. I misspelled it, okay. Then we have this warning here. I don't think you can see it, but it says use equal default to define a trivial default. So what does that mean? This here, what I wrote, is a default constructor that does nothing. and the class is empty. So that's pretty much what the compiler would generate. The compiler would generate a default constructor that does nothing. So for these cases, C++ actually has a keyword called default. And if you write equal default, what you're saying here is, compiler, please generate this for me. So let's write it for all of them. So what we did here, we would say we defaulted all the special member functions. We told the compiler, hey compiler, generate these member functions for me. And this is because the compiler won't always generate all these member functions. Each of them has their own rules of when they will be generated or not generated, or actually the compiler will delete it, which means you cannot even write one of your own. But we'll see that later. And we can also delete it. We can delete it by writing equal delete. And this will tell the compiler, hey compiler, I do not want a default constructor. And actually, if I write a default constructor later, please give me an error. So you can delete all of these if you want. So we deleted all special member functions now, so we cannot even instantiate our class. So for each of the special member functions, the compiler can actually do three things. The compiler can generate it for us, the compiler can delete it for us, meaning we cannot write one of our own even if we try, or the compiler can not do anything. So we can either create one of our own or not. The rules for these, I'll tell you the rules for the default constructor. So the default constructor is implicitly generated by the compiler if the user does not declare any constructor. So if a user declares any constructor at all, like a no argument constructor or one argument constructor or two argument constructor, the compiler will not generate the default constructor. Even if the user declares a copy constructor, which is a type of constructor, right? It's a constructor that takes another instance of my class, or a move constructor, then the compiler will not generate the default constructor. It will not delete it either, so the user can always say, I want a default constructor, compiler please generate it for me, or the user can write their own. So this is the rule for the default constructor. It is generated if there is no other constructor. And this makes a lot of sense, right? So the compiler will say, well, you wrote no constructor, I'll generate one for you because 99% of the case you want some kind of constructor, right? Otherwise you're just going to use static member functions or something like that, and that's probably not the case. So it does make sense for the default constructor. The rest, the rules also make sense, but I don't know them by heart. I don't want to know them by heart, and I don't know anyone that knows them by heart, and I don't think anyone should know them by heart. They're somewhat complicated rules. So for example, there are rules like if you write one of them, then the compiler won't generate the other one, but then it will delete that one, and then it's some crazy rules like that. So you don't need to know them. You just need to be aware that these rules exist. And what some programmers like to do is that they'll say, well, okay, the rules for these 5 here, or these 3 here, if you're talking pre-C++11, but the rules for these ones are complicated. I don't know them. So what I'll do is, if I don't need any of them, if I don't need to write any of them, just don't write any of them. But if I need to write at least one of them, I'll write all of them. So this is called the rule of 0, 5. So the rule is, for these 5, the ones except the default constructor, you either write none of them or you write all of them. And there are some people that don't like this rule. They prefer the rule of 6. And the rule of 6 is, well, you have 6 special member functions. Just know what the compiler does for them, and just remember it and keep that in mind. And that's also okay. There are some cases where the rule of 5, you actually do not want to use the rule of 5, but those are pretty rare cases. We'll not talk about them today, but maybe we'll talk about them some other time. And you know, I prefer the rule of 5 because even though you may know the rules for all the special member functions, you have to keep in mind that maybe your team doesn't know. So you have like, if you have like 5, 10, 50 people on your team, maybe you know all the rules and good for you, but do all people know? Isn't it better to be explicit and say, this is what I want the compiler to generate, this is what I want the compiler to not generate, and this one I'll write myself? So isn't it better to be explicit and let the user, just by looking at it, you know, well, this was deleted, okay, and you know, it's easier. So let's see when each special member function is called. And for the easiest way to do that, I think, is this. So I created a class called simple class, and I declared all the special member functions, and for organization purposes I just put them here on the definition here. So what the constructor does here, it just prints simple class constructor, and similar for all of them. So I wrote the special member functions that the compiler would generate if this class was empty, and then I just put a print inside them. Okay, so let's see what happens with this code here. Let's call it on debug mode so we can see line by line. So here I'm starting a new stack frame, and in this stack frame we'll talk about the default constructor and the destructor. So let's go to the next line. Here it printed on the console calling the default constructor. So here I'm declaring a variable called simple class of type simple class, and when I do this in C++, let's see what happens. It calls the constructor. Okay, so just by declaring this class, it will call the default constructor, the no argument constructor, I should say. Because the no argument constructor maybe is different from the default because maybe you wrote something else. Okay. So here another way to call the no argument constructor is just to put these curly brackets here. This will do the same. And actually you can call any constructor like this. You can write the arguments in here. And you saw that when I pressed here to go to the next line, it actually skipped one line. That's weird, right? It didn't call the constructor here. And that's because I put parentheses here. But aren't parentheses supposed to call the constructor? Yeah, if I had put 1 here, it will call the constructor that takes an int as an argument. There's no doubt about that. But if I write it like this, the compiler cannot tell if I'm saying, well, I'm declaring a variable of type simple class and it's called simple class 2 and I'm calling the no argument constructor, or maybe the compiler can think this is a return type simple class, this is a name of a function, and I'm saying this takes no arguments. So if I had it like this, the compiler would say, well, that's for sure a function declaration. If I did it like this, the compiler would say, that's for sure calling a constructor. But like this, the compiler cannot know. So the C++ standard actually says what the compiler should think, and it should be a function declaration. So this here that I did not call the constructor because I actually declared a function. And now there's a function here called simple class 2, which takes no argument and returns a simple class, and it actually has no definition, just a declaration, because I did not define it anywhere. This is a pretty common problem. Even I knowing this, I sometimes write it by accident. The compiler, any good compiler will warn you about that. unless you explicitly tells the compiler not to. If you explicitly tell the compiler not to. So let's go to the next line now. I'm doing this, and well, isn't this an assignment? That's weird, right? I'm creating a simple class here, so this should call the constructor, and then I'm assigning it, right? So it should be a constructor and then an assignment. Let's see what happens. No, it just calls the constructor, and that's because C++ thinks, well, why are you going to create a value, then assign it, and then destroy it? Let's just simplify this to be the same as this, right? And let's just call the constructor. This here below, the same thing. Notice here that now I'm using parentheses, but this cannot be a function declaration, right? There's no way to interpret this as a function declaration. So let's see what it does. The constructor as well. And now on the heap, using the new keyword, C++ will create an instance on the heap. I can use the new keyword with curly braces. I can use the new keyword with parentheses, and I can use it with nothing at all. So these all call the constructor. So we call the constructor 1, 2, 3, 4, 5, 6, 7 times. So let's now call the destructor, right? The stack frame will end here, meaning everything here will go out of scope, and when things go out of scope, they get destroyed. So let's go to the next line, calling the destructor, and it called it only 4 times. So what happened here? Let's take a look. So for these 4, excepting of course this function declaration, for these 4, it called the destructor, but for this, what actually went out of scope was the pointer. So the pointer got destroyed, but what it pointed to, what's in the heap, did not get destroyed. This will only get destroyed if you call delete on it. And since there's nothing pointing to it, we cannot delete now. It's too late. Since the pointers went out of scope, it's too late for us now. We call new, we did not call delete. We have no way of getting this address now. So these 3 here are just leaked memory. Oh no. Okay, so let's continue. Now we're on another stack frame. Let's see what this is about. This is also about the constructor. What happens when I have a derived class? Let's see what's the definition of the derived class. So the derived class has 2 base classes. It has base class and another base class. And base class and another base class are just like the simple class. They just print a value whenever their special member functions get called. So let's see what happens. I'm declaring a variable of type derived class. So it called a base class constructor, then another base class constructor, and then a derived class constructor. Makes sense, right? So here we have base class as the first one, so it's the first one to be called. Another base class is the second one, so it's the second one to be called. And then you call the actual constructor for the derived class. And now it's going to go out of scope, so it's going to get destroyed. Let's see what happens now. So it actually calls it in the opposite order of constructing. So the derived class is first, then another base class, and then base class. Now let's see what happens with composite class. Composite class has a base class, but it also has some composition going on here. It has a member class and another member class. Let's see what happens. So first of all, it called the base class. Then it called the member classes in the order that they're listed here. So makes sense, right? First these one in the order they're listed here, then these ones in the order they're listed here. And then the destructor, same as before. It's in the other order, so the composite class first, another member class, then member class, and then base class. So before continuing, I just want to say that it's always this order. The order here, and then the order here. Always. Even if you do some initialization here, be careful with that, because you might do it like this, and initialize some value here, and then this. It does not matter, because if you do it like this, pretend I'm writing the constructor here. If you do it like this, doesn't matter. It will first construct this, and then this, and then this. It's in the order they listed here, not here. So that's one thing to keep in mind. So now let's go on to the copy constructor and the copy assignment operator. And this is where it starts to get confusing. So calling the copy constructor. So first of all, I'll call just the normal default constructor. And I'm calling it for the composite class. Okay. And now I'm calling the copy constructor. The copy constructor is a constructor that takes as an argument an instance of the class. So I'm just passing the original here to a variable that I'm creating now called copy. So that should call the copy constructor. So what the copy constructor does is it calls the constructors of the base class and member classes, but it calls the copy constructor for all of them, not the default constructor. That makes a lot of sense, okay? And what about assignment? Of course, if I do copy equal original, I'm doing an assignment. So you should call the copy assignment operator. Okay, so that makes us, wait a second, that's not, what? It called the composite class copy assignment operator first, and then the other ones. Shouldn't it be the same order as this? Well, what happens is a constructor, remember you have an initialized list, so you can do things here before going into here. For the assignment operator, it's not a constructor, so you have to start doing things here. So first it goes into the assignment operator's body, and then it calls the other ones. And surprisingly, what happens if I declare an instance and call an assignment in the same line? Let's see. Well, it called the copy constructor. It did not call the assignment operator. So that's one thing to keep in mind also, that if you do an assignment in the same line as the declaration, the assignment is not an assignment. It's a copy construction. And let's talk about a slice. So what's a slice? So here I'm passing the original value, which remember it's of type composite class, but I'm putting it into a variable of type base class. So what happens then? So we call the base class copy constructor, but the rest of the values that were that may have been in the original, like the member variables and everything, they do not exist anymore. So the original is like this, and then the base class is like here, and when you copy it, you just copy this part. So that's a slice. You just sliced the whole thing and forgot about everything. And now the destructors, of course, let's skip this because it's a lot of stuff, but it's in the opposite order that they were before. And now the move constructor. We'll talk about this quickly because there's a lot of things that I can talk about, move constructor and copy constructor and everything. The move assignment operator, it's analogous to the copy assignment operator. So let's just talk about the move constructor pretty quickly. So let's first construct the value with the default constructor. And now let's call the move constructor. So for calling the move constructor, we'll use here std move. And std move doesn't actually move anything, but we'll talk more about that another day. It actually just marks this as an R value reference, which means when it's passed here, it will call the move constructor. So here we call the move constructor. That makes a lot of sense. It just called it in the order that we would expect. So let's now talk about some homework. Yeah, there's homework. So consider this class hierarchy. You have a class A, and then a class B which inherits from A, a class C which inherits from B, then a class D, a class E, and then class F which inherits from D and from C. And it has a member variable of type E. So what will be the constructor, the construction order, if we run the next line? So if we run this line here, where I'm creating a variable of type F, what will happen? So can you write code that calls F's move constructor and move assignment operator? And can you do it without the std move like we did before? Can you create an R value reference without std move? I'll let you research about that or think about that, or if you already know, don't do it. Next homework. Which special member functions do these lines call? So we have here of type composite class a variable called WTF, and then I'm passing inside it, I'm constructing in place here a composite class type. So composite class instance. So it looks like this would create an R value, and then I'm calling a constructor with an R value. So it looks like it will call the move constructor, but it doesn't. Run this code and see what happens. That's the homework. And then after that, take a look at this. So now the same thing, but instead of just passing here an R value of a composite class, we're passing an R value of a composite class constructed with an R value of a composite class constructed with an R value of a composite class. That is default constructor. So see what happens when you run this code. Now go to classes.cpp here, and I'll put this code somewhere in the description. Check the special member functions marked as to do. So if you go there are some here that are marked as to do because I'm lazy. Can you write them to be the equivalent of what the compiler generates? So next one. There's a bunch of questions here. Read and answer them. And then homework 4, what is the rule of 6? Well, we already talked about that, so yeah, so rewind the video and see. And what is the rule of 7? Go to, search for this on the internet, and you will find the rule of 7. Then there may be more like rule of 8, rule of 9, rule of 12, rule of 56. C++ is just like that. So do your research, see what's best for your life, for your project, for your team. Tell me later if you don't think that the rule of 5 is the best. I think the rule of 5 is the best one out there. So it's the simplest one that works most of the time. So if you disagree, please let me know. Maybe I'll change my mind. And that's it, guys. Thanks for watching. Leave in the comments what do you want to see and what did I say wrong, because C++ like this, we always say some stuff wrong. So correct me, please, and bye. Bye, world.